Welcome to a little bit of fun in the lab, networking with Fish Style. Today we're going to put our network detective hat on, our network detective badge on, and do some fundamental CyberFlood troubleshooting. So we'll be using the environment that I've already been using for all of the rest of the CyberFlood series up to this point. And I do already have some fun troubleshooting that I'm going to inject, and we're going to do some ride-alongs on later. In those ride-alongs, I'm trying to keep it short and focus just on that specific problem. So I will not be actually explaining in there about the fundamental methodology troubleshooting that I would be doing first. So we're going to go ahead and talk about that here, and then the other ones will just reference this foundational. So number one, first and foremost, we're going to review the diagram that we've been using. There's a couple blanks in there. For example, there's that little line on the left that says E11, E1, but it's just a line. So we're going to fill in some blanks and then make a new diagram for troubleshooting that will talk about all of the different hops that we could be losing packets on or having issues with. We're also going to talk about the obvious first. Are you cabled correctly? Are you connected to the right cables, etc.? Are the interfaces up? Then we're going to walk the packet from the client to the server. Each one is a troubleshooting point. I'm not going to walk it back because it's going to be similar. And again, this is just the foundational methodology of troubleshooting. So once we get there, you'd use similar to get back again, of course. And then there is one thing that I always do now. I have a team lead named Keith Brister, and I've worked with Keith Brister for years. We used to do CPOCs together, and now with my new job, he's my team lead, and it's just great to be working with him again. Anyway, so I was new to everything. I'd be like, it's not working, it's not working. And he would say, well, did you ping the CyberFlood VRs while the test is running? I'm like, oh, no, I didn't do that. Go ping the CyberFlood virtual routers while the test is running, then come back. So after hearing that a number of times, I did see the value of pinging the CyberFlood virtual router. So that is one thing that I do tend to do. It doesn't really talk about it in a specific flow, just one of those things that I tend to do now. So we're going to go ahead and cover these things. The first one is we're going to talk about the diagram. So if you look at the diagram on the top and the diagram on the bottom, the first thing that you're going to notice is that instead of having that vertical line with Ethernet 111 on the left and Ethernet 1.1 connecting to the next generation firewall, we actually have a Nexus 9K. Now the Nexus 9K is layer 2 only. And so typically, except for one of the videos that I'm going to do on a ride-along, Ethernet 111 is in a switch port access, and Ethernet 1.1 is an access port, and I have the VLAN the same on both sides. So it's just layer 2, and I'm passing through it. And so 10.11.0.0 extends from the CyberFlood virtual router to also the next generation firewall. The other thing that you will notice in this time is that I actually took the CyberFlood virtual router and I moved it inside of the CyberFlood. The top diagram I had kind of as a logical, you have the host, then you connect to kind of sort of a VR, but really the VR's inside of CyberFlood. So we have to remember that so we remember where we're troubleshooting. So we have that Nexus 9K on the left. What a shock. We also have it on the right. So the other thing that is different between the top and the bottom, besides the two Nexus 9Ks layer 2 only, and also the virtual routers being inside of the CyberFlood bubble, is that there is this construct between the CyberFlood virtual and the clients. It is not, I touched on it in one of the other videos, it is not a cable, okay? It is you connect the clients to the virtual router for those clients that is inside of CyberFlood. If you connect the clients to the wrong virtual router, you will also have an issue. Similarly to if you didn't cable it to the right thing. So that's over here on this side, and we also of course have the same thing over on the side with the server. So that is one thing that you have to pay attention to, is that you took your clients and your servers and you connected them to the virtual routers that are for them. And what I mean by for them, they have the static routes in there, etc., to get to the other side. or whatever else, VLANs or whatever. So this is the environment in the diagram we're going to be moving forward with. And what we're going to do is we're going to start with destination as if the test had just gotten kicked off. So we're going to kick it off. The client's going to go ahead and go to like destination 10.201 something, okay, over on the servers. And then we're going to go hop by hop and see what our methodology would be at each hop. So let's talk about the obvious first. So the obvious first is, you know what? Do you have the cables properly connected? Are the links all up and configured properly? Now, these are the obvious, no matter what you're troubleshooting. There is one additional thing that is on top of that from a CyberFlood perspective. There is something called a CyberFlood queue. So the question is the CyberFlood queue that you're using the one that's connected to the cables that you're using? So your test will refer to as a CyberFlood queue. The CyberFlood queue is referencing what you're reserving and what ports you'll be using in that test. So are you pointing to the right one? So that's the obvious first. So we've talked about reviewing the diagram. We have the new diagram, the obvious first. Let's go ahead and walk the packet from the clients to the servers, because these are our troubleshooting points. So we're going to start with the client. So we just kicked the test off. So when we just kick the test off, the first thing, of course, is that the clients are going to go ahead and send out whatever protocol that they're doing. Their destination IP address is going to be 10.201. something. So what is the first thing that's going to happen? Well, the first thing that's going to happen is, don't forget, we are still inside of the CyberFlood at this point in time. So what we have to do is we have to make sure that the next hop, and I say next hop loosely because it's not that the clients are specifically configured that this is the next hop. You don't do it that way. You just basically connect the client subnet to the client virtual router. So the first question that you have to ask yourself when the traffic goes out is the client connected properly to the right CyberFlood virtual router? So that's this part right here. So that's within CyberFlood that you would be troubleshooting that. So assuming that the answer to that is correct, then the traffic gets to the CyberFlood virtual router. So now the traffic is at the CyberFlood virtual router. So at the CyberFlood virtual router just got this packet that's destined to 10.201.x.y. So of course it's going to have to know, so the CyberFlood virtual router has to know who the next hop IP address is. You do that by configuring that in the CyberFlood virtual router. So is that proper? That's like a static route. Is that properly connected? Is that properly configured? What is the next hop? So from our perspective, what we want to have happen is we want the next hop to be the next generation firewall, in my case, a Firepower 4120. And that's going to be IP address 10.11.0.1. Now, the CyberFlood doesn't know exactly what is between it and that. It just knows go out that port that is on the custom queue that the CyberFlood virtual router is connected to. So all it knows is go out that port. So if we go ahead and that is configured properly, then the CyberFlood virtual router, the CyberFlood will know that it can send that traffic. It's supposed to go out this port. Now, it happens to, in our environment, go to a Nexus 9K. The Nexus 9K is layer 2 only. It still has to get through this, so this is a troubleshooting point for you. So this is going to be basically a pass-through. In our situation, typically, but not all the time, Ethernet 111 and Ethernet 1.1 are both switch port access, and they're in the same VLAN. So I just pass right through. The packet comes in, goes right out. The Nexus 9K, again, is layer 2 only. And it just continues on to 10.11.0.1. Remember, though, they have to be configured properly. So if Ethernet 111 is in one VLAN and Ethernet 1.1 is in a different VLAN, you have to have this as a troubleshooting spot because it could be getting lost here. Now, in some situations, I might do a trunk to the CyberFlood. So Ethernet 111 might be a trunk, and then Ethernet 1.1 an access port, or vice versa. But again, we have to make it through here. So assuming that that's set up properly from a layer 2 perspective, then we will go ahead and take that packet and it will go to the next generation firewall. Now, once we go to the next generation firewall, obviously the firewall needs to know, again, who is the next hop for destination IP 10.201.x.y/16. Okay, so we have to know who the next hop is. So we do that in our situation with a static route. Could have been a dynamic route, could have been whatever you're doing in your next generation firewall, or if you have a different device under test. Mine's a next generation firewall, and I'm currently using statics to try to keep all of these YouTubes extremely simple right now for the CyberFlood. So our next hop is 10.21.0.3, which is the CyberFlood virtual router on the server side. Now, what you also have to remember in my situation, where a lot of times the device in the middle is a firewall, that firewalls need to allow traffic. So don't forget to check that as well. So check for, if this is a router that you have or whatever, check for ACLs. If it's a router also, you might want to see whether or not you might have, know who the next is, but you might have some override, access list on there, PBR, whatever. So all that has to happen, and assuming all that happens, then we go ahead and we send it out. Now, we know that we send it out Ethernet 1.4. The firewall knows that. And so again, it gets to a layer 2 only. Nexus 9K happens to be the same one as I have on the client side. So we go into the Nexus 9K Ethernet 1.2, and I want to go out Ethernet 1.15. Again, same VLAN, or one's a trunk, one's access port, but we have to get through that layer 2. So that's a point that you also have to troubleshoot. Assuming that you're good there, you go ahead and you get moved on, and you get to the CyberFlood virtual router. Now, what you have to remember is we are back in the CyberFlood world again. So you're going to have to go back over to the CyberFlood for this. And we're going to hit the CyberFlood virtual, and the CyberFlood virtual has to know what the next hop is to the servers. Again, I put next hop in parentheses because, again, it is this construct of tying the server virtual router over to the server subnet. Now, once that's good, we're all the way over to the other end, and these are our different steps. So when we do the other videos, it's going to be very, very important for you to go ahead and know that we're going to be stopping at each of these steps. These are the different places where we could be losing packets or corrupting packets or whatever. Now, as you see, most of this is just routing, except for that weird construct between the virtual router and the client, the virtual router and the server. Everything else is just, what's your next hop? Can you get through? Is it allowed? So never underestimate the power of just the basics. So always make sure you get the basics right first, then start diving into the CyberFlood. So we've reviewed the diagram. We've done the new diagram for the troubleshooting that we'll be using for all of the other videos. We've covered about the obvious first, walked the packet from the client to the server, modified and looked at all of our different troubleshooting points. And now for the last thing. So while the test is running, I should be able to go into my Firepower 4120. And from my Firepower 4120, I should be able to ping 10.11.0.3, the client-side VR, and I should be able to ping 10.21.0.3, the server-side VR, while the CyberFlood test is running. If I cannot ping them, that is a problem. So let's go ahead and go into my secure CRT and open this up, session you open it up, session manager, and go into my Firepower. So we're going to go ahead and we're going to do a ping 10.11.0.3. This is my client side VR, and we're good. And ping 10.21.0.3, and that is my server side VR. If I could not ping them, I probably have, because when I ping 10.11.0.3, I'm pinging it from 10.11.0.1, which is the firewall. So I'm in the exact same subnet. So if I can't ping these, we have a more basic fundamental problem. But we can ping them. So thank you, Keith, for always telling me, have you pinged the CyberFlood virtual routers? So we ping the CyberFlood virtual routers, and that's pretty much it in the nutshell. So basic CyberFlood troubleshooting, check the obvious first, just like you would with everything else. Walk the packet, and I've explained what you need from a packet walk that is beyond just the routing, and then also do the ping of the CyberFlood virtual routers while the test is running. Again, CyberFlood troubleshooting methodology, we'll be using this and referencing this extensively on all of the other videos. See ya.